Hello, I'm Jeff Dahlin. I'm an applications engineer with Cypress Semiconductor. I'm going to demonstrate the capabilities of our lithium-ion battery charger, which is based on our Cy8C21x23 PSoC. This is a 4K flash device in an 8-pin package. What I have right here is a demonstration board that actually has a 16-pin package of the same device. Even though the design in there only requires 8 pins to charge the battery, the extra pins are used to communicate with our control software that will show the voltage profile and the current profile while the battery is being charged. Over here I have a voltmeter and a current meter, and down in front is a battery emulator where I can just turn the knob on the battery emulator to change the voltage, the apparent voltage of the battery, to make it look like the battery is being charged. What I'm going to demonstrate here is a typical charge profile. When I connect the thermistor to the PSoC, it tells it that a battery was plugged in. Right away, the charge current steps up to about 80 milliamps, 76 is here, 73. The battery voltage is only 2.6 volts, so this is the activation mode, not rapid charge. As I increase the battery voltage and it crosses 3 volts, which is a programmable parameter within the include tables of our project, you can see that the current steps up close to the rated voltage of the battery, 500 milliamps. And you can see that step change on our graph also. As I continue to increase the voltage by turning the setting on the battery emulator, I can get the voltage to approach 4.2 volts. When it reaches 4.2, the current will be reduced. As you can see, it's now dropped down to 200 milliamps. I crank the knob a little fast. In real life, I'm going back up, it would be more gradual as it came down. And this is to keep the battery voltage from exceeding 4.2 volts. As the battery charge continues to increase, the amount of current to maintain 4.2 volts reduces until it drops below the termination current of 60 milliamps. If it stays below 60 milliamps for 10 seconds, the charger decides that the battery has completed its charge and shuts the current off. If the voltage then fades and drops below 4 volts, it would restart. I can't get below 4.0 volts. It would restart the charging to recharge the battery, at which point it would repeat the same termination process. All of the parameters, the battery voltage, the charge currents, the timeouts that occur if a charge cycle lasts too long, and the thermistor parameters are all easily settable by changing parameters within an include file, or a header file actually, within the project. So if you want to change it from 500 milliamps to 600 milliamps, you simply enter in a 600 into the include file, recompile the project, and it will now work for 600. Right now we're going to take a quick look at some of the measurements and the accuracy of those measurements. Here is our control software running, and you can see in the upper left corner of the bar is VB, which is the battery voltage, and I, which is the current. Right now it says that the battery voltage is about 2.65 and the current is bouncing around 74 to 80 milliamps. As we can see what the meter says, it says 2.63, close to 2.65, and the current is 76 milliamps. Let me go ahead and step the current up a little bit, the voltage up a little bit, and we'll see it go into rapid charge. Okay, now we're seeing about 3.5 volts and right at 500 milliamps. Over here on the meter we're seeing 3.55 volts and about 500 milliamps. Next we need to be looking at the termination voltage of 4.2 volts, which is the most critical voltage. I'm going to turn the voltage up, and we should get a limit on the current as it reaches about 4.2 volts. There we go, 4.22 volts, and the current has limited at 3.77, If we run over here, 4.19 volts, and again the current is limited at 0.37 amps. Let me summarize and add a few pieces of information. Our 8-pin package is, our 8-pin design is targeted at 500 milliamp and less charging currents. The limitation is not the PSoC, but in the pass transistor. With higher currents, the heat becomes significant, and it requires a larger, more expensive transistor. The alternative is to go to our 16-pin package, where the additional pins can be used to control the voltage out of the power supply, such as providing controls to a flyback power supply. This will limit the voltage drop across the pass transistor, and a less expensive transistor can be used. In this case, the actual charge current is limited by the features of that transistor, not by anything within the PSoC design. We also have an 8K version of the same part with the same architecture for the analog. This would allow somebody to add more features to their charging. So I hope this answers all your questions. If it doesn't, it's very easy to get a hold of us through our website at www.cypress.com. Thank you.